Okay, thank you. So yeah, hopefully I will not run out of memory today. I have a few Java processes running in the background and probably Slack, so let's keep fingers crossed. Thanks a lot for participating in my session. Again, today we are talking about API integration testing. We will focus on test containers, WireMock, and actually my goal is to show how to use these tools together and to show some examples. I plan to finish the talk maybe in 30 minutes, and then we will maybe 35, and then we will have more time for demos, questions, and ad hoc discussion for particular frameworks. So my plan that I show just core Java and maybe some Spring Boot examples. Okay, let's begin. So you probably know me from the Jenkins community. I actually started contributing to Jenkins in 2012. I've been Jenkins core member and board member ever since. So just in case, I'm sorry. But yeah, I really like Jenkins. I really like automation, all kinds of developer tools. And this is why this April I joined WireMock to help with a growing community and ecosystem around it. I'm also a contributor to many other projects. Maybe you have tried test containers, what I'm presenting today. And given my embedded and hardware background, actually I created test containers for C, C++, and working on that. And yeah, I also participate in quite a lot of foundations and organizations. Today, I represent WireMock. So WireMock, you probably know about it as an open source project. It's one of the most popular API modeling or API mocking, if you wish, tools. And there is a small company, WireMock Inc., which actually provides WireMock as a SaaS or as an on-premises Kubernetes edition with fancy UI, some additional features. But today, I focus on open source. And today we talk about open source WireMock, open source test containers. And if you wish to discuss anything else, we can do it after the talk. So let's go to our developer life. So every time you build something, you commit something, it runs continuous integration, and then sometimes things fail. Sometimes they fail during CI, sometimes they fail in production or in staging. But in any case, you have to fix these things, and it takes a lot of time for every developer to troubleshoot things, especially when it comes to interaction between different components, because it's complex to produce, it's complex to analyze, to debug. Sometimes debugging is just not possible for runtime applications. And this is something that creates a lot of issues for us during development. The question is how you automate it. We try to automate everything. And for that, there are integration tests. Yeah, normally at this point, I ask the audience, how often do you do integration tests? And actually, the answer is quite mixed. Why? Integration tests are normally complicated. They require a lot of time investment for building them, for verifying the results, and also for maintaining these tests. There are normally a lot of technology stacks involved, many teams involved. There is, of course, configuration matrix hell if you maintain multiple frameworks and need to test against each other. And overall, this becomes quite difficult to test your application. And sometimes we just delegate it to other teams or do not do as much integration testing as we could. These days, most of applications become distributed. They use various kinds of APIs. They can be synchronous or synchronous APIs. So, for example, if you use Apache Kafka, in my definition, you still use APIs. If you use SNS, if you use GraphQL, gRPC, or just REST API, all of that is APIs as well. They have different types, they have different specifics, but normally APIs is what you use to interact between different components. Moreover, if you have a front end and back end side, normally you also have a kind of API between them. For example, WebSocket or just REST API. And for us, the normal problem is that not so many people actually invest time in doing API tests as much as they could. And if they don't do that, they basically do not do integration testing of the apps. And it can be understood because it's complex to do that. But still, it's quite important for projects to do integrations. Sometimes things happen. In my history, I broke Jenkins core build and weekly releases multiple times. So I definitely know value of integration tests on my own. And this is what I highly recommend doing when you develop code. For me, there have been 4 types of integration testing, 4 approaches to them. So, of course, you can test against production, against staging. For example, if you develop a GitHub client, you can test against the real GitHub setup or against local GitHub enterprise. This is quite accurate because it uses the real server, but at the same time, it requires quite a lot of effort to maintain this infrastructure and to test against it. Even with modern tools, it becomes difficult. On the other hand, you can mock at the code level. So in Java, we have frameworks like Makita, PowerMock that actually allow to isolate particular bit of the code. The problem with these frameworks is that they actually instrument your application. So they modify the bytecode, they modify the execution flow, and what you test is not actually what you will have in production. So there might be some glitches related to JDK. There might be also, you also do not test the protocol stacks, so it's quite limited. And there are 2 approaches in the middle, which are something I normally recommend for integration testing. So, for example, in Jenkins, in WireMock, our recommendation at the moment, do not use PowerMock, do not use Makita. If you need to mock something for integration testing, mock it at the service provider level. So the idea is quite simple. You build a model that mimics your service provider, but at the same time, your application remains the same. So you can test, you can debug what you will be actually shipping to production. There are ways to do that. So of course, you can just put your application into a test container. I hope by this time, almost everyone knows what test containers is. If not, I will do the introduction later. Or if you don't have this application or it cannot be containerized, for example, you have Oracle database with license requirements, or if you have just a service that can be put in container, you can actually mock it. And this is what WireMock is for. So these are 2 tools I would like to talk about today. And for us, these tools are actually quite helpful because they intend to simplify the integration testing. Normally, what we used to do that we build something, that we run unit tests, probably as a part of continuous integration, but we normally do not run the whole integration test suites as a part of within our CI. It delays the feedback. It also leads us to missing issues. And the key point for that is that it's difficult to develop and maintain that. And with proper frameworks, we actually can speed up integration tests and we can simplify maintenance of this integration tests. And if it's done, basically integration tests become just tests, same as unit tests. If you use similar frameworks, if they're fast, you do not really care about where they run. And this is what test containers and WireMock allow you to achieve. Okay, I will do quick introduction to test containers. If you want, we will see examples later. But if you're not very familiar with this technology, please bear with me. It's still quite simple. So test containers, they basically leverage containers and provide clean environments and simplified services that can be just used within your test and just discarded later. And this has been super popular in testing since Docker became a thing. So in 2013, 14, first versions of Docker actually got quite a lot of popularity thanks to the developer experience. And there were a lot of frameworks that built test automation and provided test integration testing capabilities using Docker. And test containers is one of them. So test containers positions itself as unit tests with real dependencies. To be honest, I disagree with that because I consider test container is still a model because it's a simplified, lightweight version of the solution. So you cannot put a production scale database in a test container, but you can still put something and do integration testing. Test containers is open source. It started for Java, and now it has a lot of integrations and a lot of implementations for different technology stacks. What is more important, it has native integrations with modern frameworks. For example, if you develop for Spring Boot, test containers is a part of Spring Boot automation tooling. If you use Quarkus, now test containers has a developer service that allows to run every model of test containers quite easily for Quarkus development. And speaking of models, one of advantages of test containers is that it's not just a simple Java framework for integration testing. It actually provides models for different technologies, for example, K3s, WireMock, Selenium, pretty much every database. And the idea of this model is that it's SDK that basically provides additional APIs and methods to simplify testing, to implement assertions, etc., etc. So how it looks like, if you use JUnit or any other XUnit framework, it normally looks like a declaration. You say that you run your test with test containers, you define a container. Here I use WireMock of a particular version. I also pre-configure it with a file from resources. And then I just write my test without caring about the service. So test containers as a framework takes care of provisioning the service, of allocating all ports and providing them to the application. And when the test completes, it can tear down the service. So in my case, I just write the test and I assume that the environment is provided. If you have multiple containers, you can declare dependencies between them, or you can just use a Docker Compose definition. But what it really gives to us is a really simple test implementation. And one thing that test containers also has quite a lot of capabilities to make it fast. So it's not just a container that provision for each test. You can suspend containers, you can reuse them. You can have on-demand build that speeds up packaging. And sometimes using test containers is much more simple and much faster than using the native solution. So for example, in Jenkins, we have Jenkins test harness, and now provisioning Jenkins in a test containers is faster than provisioning it with Jenkins test harness on the local JVM. And also I don't have to care about all potential class loading conflicts, which actually saves me ounce of time. And of course, about resource management, etc., it's also something that test containers takes care of. So every container you provision will be eventually terminated, even if you write test improperly, and it's also quite a good addition. So I will show a demo for WireMock later, but yeah, maybe I should show it now, actually. Why not? So how it looks at real, again, depending on your framework, it will look slightly differently, but here I can just show you hello world test, so basically the same as I presented. And yeah, this is a definition. We use JUnit 5. For JUnit 4, there are also rules. And for hello world, we can just run this test. So my machine is really saturated about memory, so it might take some time to actually start up, but let's see. Yeah, it takes much longer than I expected because usually it's just a few seconds. Oh, but here we got 20 seconds. We don't have any log, etc., because I guess this is how the test configured. We can take a look. But normally what I do in this test, I just send a request to the service, then get a response and verify it. And you can see that I actually use an abstract test. So if I go here, what we can... Okay, sorry. Yeah, here you can see that my definition, so I just provision a WireMock container, and this is why I do not see any logs, because I haven't set up a following of logs. You can connect logs to your JUnit test by just a simple command. But yeah, in principle, it's just a server that works quite well and implements everything inside. So you can see that there is a lot of logic for this particular test, but it's just simplifies my own implementation, and later we can see slightly more simple examples. Okay, so these tests use WireMock. So WireMock is another tool I wanted to show today. And the idea of WireMock that instead of provisioning a real container, you actually take a definition of a service, and this definition will be modeled as a real service. WireMock started as a Java project. Now it's available on many technology stacks and platforms, and also it has quite a lot of integrations. And the idea is quite simple. If you cannot deploy a test container, for example, if your service just doesn't exist, or if you cannot deploy it, if you want to experiment with service that you just imagine or you want to update, you can use the definition. And the definition is normally quite simple. So you say that if I receive particular request, then I send a response. And here's configuration JSON that you can use. Soon you will be also able to use YAML configuration, and yeah, it's quite handy. At the same time, it's just a basic feature. There is a lot more to API mocking, but this is how it normally works. If you like it, you can configure it in UI, but normally you would, of course, do it in the code. And in the code, we provide WireMock basically as a Java library. You include it, and then you just write tests. You can use a test container, or you can use a native implementation that is just provisioned as a rule within the same JVM. Yeah, if you want, you can run definitions for any language you want. It's just a really simple example, but actually, there is quite a lot more to API mocking. You can see things in the documentation, but for example, there is advanced matching capabilities. For example, if you submit a form, you can extract fields. If you submit JSONs, XMLs, you can actually use XPath or similar filters to retrieve the proper data to verify them, or you can just process binary files if needed. The same for response templating. You can actually make it dynamic. You can use microscripting. You can just inject particular fields like dates. You can inject various delays. You can generate gibberish data if needed. And also, for everything, you can have not just static behavior, but also stateful one. So, for example, you can have global variables to implement things like counters if you emulate, let's say, OpenSearch. And all of that falls under mocking. It's not something I'm showing today, but you can find a lot of documentation. And actually, another thing which is quite cool about WireMock, you can record the execution. And then once you record it, you can reproduce it. So if you don't have open API for your service or other kind of specification, you can still reverse engineer that, retrieve responses, and then reproduce them for you in your integration tests. So this is what WireMock does very basically. And again, it's available for many technology stacks and implementations. So for example, if you use Spring Boot, there is a library that integrates it quite well. The same for Micronaut, the same for Quarkus. So there is a developer service you can use. And for example, if you write in Kotlin, if you write in Scala or in Clojure, there are various things like DSL bindings available that you can try out. So yeah, there is quite a lot of platforms and integrations, but everywhere you write basically the same, and we try to make developer experience as simple as possible. And if I have enough time, I will definitely show you Spring Boot example. Okay, So the question is, with these frameworks, is why do I talk about two different things and what I recommend? The answer is that I do not actually recommend anything particular. It depends on your use cases and implementations. And actually, these frameworks can work together quite well. So WireMock offers an official test containers model, which is available for Java and other languages. And this model actually bridges the gap. So you can use the same test container and the same API at different stages of development for your application. So for example, when your service is just not ready, it doesn't exist, you can use WireMock to start to prototype, including live development. And then when your service is implemented, you can actually just package it in test containers and reuse as I have shown before. So this is how it works, and maybe I will show you a slightly more complicated example. So, for example, this is actually what I'm showing here is a part of WireMock Docker integration test. So we have an official Docker image on which we actually built the test containers models. Sorry, WireMock Docker. So if you go here, you can see that it's quite a standard classic Docker image, and you can see CI fails. I have no idea why. So nightly builds failed. I will investigate it later. But this is an image which provides WireMock, which provides configurations. And here we use test containers to actually do integration tests. It's quite inverse because actually instead of testing the client, in this case, we use the server side. And here, if you just go to integration, well, there is no real code here, but there are integration tests. And each integration test just verifies particular capability. So for example, we have a webhooks extension, and in webhooks extension, we test capability of WireMock to send particular information and metadata. For example, if particular event happens. So let's say we use WireMock to set up a debug point, particular API is hit. What we can do with WireMock, we can send a webhook to our development service. And then basically we can provision all services, let's say in debug mode right away. This is what I already did with Gitpod, and well, it has been quite handy. Here, so in this test, again, we just provision a number of services. You can see that it's still one service. I'll probably switch to IDE because it's a little bit more convenient. Okay, so yeah, this is basically an extension. And in this extension, we provision logs if needed. We also pass mappings. And actually here we set up a second service which would be receiving the responses. So you can see that there is quite a lot of logic, but it's a synchronous execution with a timeout. And what we can do, we can just launch this test, which will verify that actually a webhook arrives. Hopefully this time it happens faster because at least something should have been cached in IDEA, but let's see. Yeah, something like that. So you can see that the output is still quite boring. We actually connected log consumer, but in this case, we don't produce logs if everything is going right. So you can see that, yeah, it's all okay. But what we can actually do, let's try breaking the thing a bit. So for example, I can take an old version of WireMock. Okay, let's start from that. I have no idea what will happen. And here, for example, we disable the extension. So it shouldn't even start, I guess, but let's see. So what should happen in this scenario? the WireMock server should fail to start. At least I hope that it does. And after that, we should get an error with some logs and information. Or maybe it will just hang because WireMock 2.x doesn't have enough diagnostics. It didn't help. It didn't hang. And here you can see that basically it failed with not found exception. It's just container that doesn't exist. So yeah, it's not exactly the use case I wanted, but still we get error. If you provision the broken instance, if it starts up, you basically get the same. The log is provisioned here and you get all the insights. So this is a very simple example. And again, if you want to deploy something more complex, you can use capabilities of test containers. And one of the things I really like about it, that it can do integration testing. And you can actually use WireMock, not just instead of your service, but as a proxy in your service. And you can use it, for example, for fault injection. So if you develop the service right, usually it's quite difficult to break it. At least all of us hope so. But if you need to emulate particular failures, for example, if an availability zone goes down or if database goes down, you can actually do it with WireMock, and you can inject particular responses to emulate behavior of the service that cannot be really reproduced. You can also capture all the communications and then use WireMock as a service for assertions. You can query the communication history. You can extract particular data using WireMock matchers. And it's, again, quite handy for your integration tests because you can actually trace what happened in the communication channel. So WireMock basically becomes Wireshark for your API protocol. And last but not least, you can also verify the protocols. So for example, if you have open API definition, you can actually verify the behavior against this open API. So in WireMock Cloud, we have just contract testing as a feature available. In WireMock, you can do it locally in your test by comparing using open API libraries. So this is also quite a handy use case. And this use case becomes even more handy thanks to advanced test containers features. So if you go to test containers site, you can actually find quite a lot of things I'm not showing today. But one of these things is Docker Compose. I have no idea when it is, but well, I'm not using ChatGPT today, but we at least have classic Google. So let's say Docker Compose, and yeah. So there is a Docker Compose model, and the idea is that you can just provision Docker Compose with dependencies between your services, and it will interact quite well. So you can provision a subsystem that includes WireMock. Or if you don't like this approach, actually you can use the same just with test containers definitions, because if you operate in IDE, you can easily provision 2 or 3 services that would be just using the test containers definition. So for example, one WireMock, and then we can provision. So for example, well, Postgres would be a better idea, but let's say a local stack. It's not loaded, so it's not going to do something. But one thing you can do, even if your service doesn't actually have an implementation, there is a generic container. So it's basically a very basic API you can use, and you can provision this container, I believe. Yeah. And then, so let's see. For example, we just take whatever version of local stack. I'm not even going to launch it. I'm just showing you can configure local stack with all the configurations, etc. Actually, there is a container for that. And then there are methods like depends on. So you can easily say that local stack depends on the WireMock. And basically, well, normally it should be in opposite direction, but yeah, in this case, test containers will be firstly provisioning MockServer. It will verify that it started using health checks, etc. And only after that, it will provision local stack container. And actually, it's also quite a good thing to keep in mind because, health checks, etc. This is also something that is addressed by the model. So I will just download sources from our model. I don't want to open it idea. But here you can see that there is quite a logic hidden within the test containers model, including initialization, compatibility checks. So all of that you get from models out of the box when you develop your application. Okay, let's just finish with the slides because I've started segueing here and there. Okay, so what I presented today, again, it's available for other frameworks like Quarkus, Spring Boot with native integrations with a lot of additional features like service definitions, integration testing, and the same is also available on other languages. So for example, if you develop Python, you can basically use the same container and you can use a very similar syntax. Well, Python syntax is terrible, but it's basically the same concept-wise. And what is an advantage is that if you have a shared model implementation, if you have a good Docker image with a lot of capabilities, you can make your applications and testing portable between multiple client applications. And for example, the same for Golang, again, it's quite worthy, but you can basically do the same and do the same integration testing. For other frameworks, again, for WireMock and Testcontainers, you can refer to our documentation. We spent quite a lot of time documenting different use cases and putting them. It always can be better, but you can find the examples here. So for example, for Quarkus, you can find a model on the Quark-awares for WireMock extension. Also, you can now use developer service by basically provisioning WireMock within test containers. So we do not want to build our own developer service at the moment because we leverage test containers as a platform. And for other things, so for example, if you develop in Kotlin, there are fancy DSL bindings that make it quite easy for Kotlin development. Also, if you use CoTest, is a Kotlin test framework, there is also integration that it makes it even easier than if you use in JUnit, and pretty much the same for other frameworks. So there is quite a lot of integrations you can find for your particular technology stack, and just ask a question so we can discuss what it could be for your stack. So I've already briefly presented the demo, key takeaway for you before we switch to Q&A that consider moving integration testing to just development phase with WireMock and test containers. It becomes easier. You can build a test framework for your particular service. So in test containers, it can be a test containers model, or you can just build whatever JUnit extension to actually simplify verification of your service and development of integration tests for basically component developers. So for QA team, for software developers and test, you can provide performance testing framework for with test containers if needed. You can provide integration tests. You can also do system tests and by provisioning the whole system with Docker Compose or with multiple containers. And you can hide all this complexity in your implementation. So for developers, it becomes simple. And test containers and WireMock, these are two services that coexist quite well. So I already mentioned how I select them, but general recommendation is if you can use test containers, if it's convenient, you should rather use test containers because it provides better test coverage for your application by testing the server side, by making it debuggable, and it improves your developer experience. But if it's not possible, so for example, if there is just no server implementation, if it's not lightweight enough, or if you cannot emulate cases that you actually want to test, this is when you use WireMock. And in such a case, there is definitions like OpenAPI that make it quite easy. You can import the OpenAPI into WireMock thanks to WireMock Cloud conversion feature, and then model everything in just a few minutes. So that's it. If you want to get started, check out the docs. As I've said, there is quite a lot of use cases, guides there, and also demos. We keep expanding them. And the same is being done by the test containers team on their side. So there is quite a lot of guides and integrations. And I think I have plenty of time for Q&A. So thanks a lot for listening. I definitely want to show a Spring Boot example. And if you want, I can show other examples. So we have plenty of time. And going forward, I just can adjust to questions so that we make something interesting for your particular application. Okay, so there is one question in the chat. Any hints how to test a flow like post something and that get it using WireMock? So the question is, where do you post? Because normally, so this is not something I can easily answer, because if you post to the external service, you can just use Java client and deploy the application. And then once you post it to the application, you can definitely proxy all the responses, including get, through WireMock. Or WireMock can serve the get response, but there won't be something like post-processing logic. So I'm not sure what exactly to answer about this use case. Okay, any other questions? So what kind of tool you recommend for configuration repository? So I always recommend configuration as code. And for configuration repository, specifically for WireMock and Testcontainers, it's usually a bunch of YAML files or JSON files. For that, you can use common development tools. So for WireMock, there are JSON schemas. So you can use Visual Studio Code or IntelliJ IDEA or any other framework that consumes JSON schema. There are also specific plugins like WireMock for JetBrains. It's a commercial plugin by one of WireMock contributors. But you can use them to improve your developer experience. For test containers, it's basically the same. You can rely on the frameworks available out of the box there. So probably I can show it to you. So this is for JetBrains. So this plugin you can try out, but it's not really necessary for common editing. But you can see that there is quite a lot of features that simplify that, including editing JSON schemas, injecting various macros, because WireMock is all about macros. And then once you have these files, you can just commit them to the repository, and the WireMock will consume them. For WireMock as code in general, wiremock.org, and here in the documentation, you can find all the information about including configurations, etc. For example, in Docker guide, and if you need, you can build other containers. For test containers, there is no configuration as code per se. For that, you just use models and you write the most of the things in the code. But there is actually one thing that can help you. So there is a tool called Testcontainers Desktop, which actually provides some additional configuration capabilities. And this is a tool by Atomic Jar, a vendor behind Testcontainers. And when you develop, you can actually manage some configurations of containers there. And then you can also export these configurations and reuse them, for example, in Testcontainers Cloud on in your local deployments. So whether it's what you need, I'm not sure, but it's something you can test. Okay, just a second. Am I still screen sharing? No. Yeah, I'm still screen sharing. So, okay, so we have a few minutes left. So what I'm going to do, you can still ask questions meanwhile, and I will see what is our Spring Boot application doing at the moment, because I started it right before the presentation. And yes, so it's So there is a demo I wanted to show, which one we created together with Oleg Nenashev from Atomic Jar for DevOps. And then, just a second, so you can find the demo I'm showing either in the presentation on the slides, or you can just find it here. Well, Testcontainers WireMock demo. Conveniently enough, it's the first one. And what this demo actually does, it provides the application that can actually talk to external service provider. It's all a Spring Boot application, and it's implemented by Spring Boot controllers. And you can use different implementations. So you can run tests against WireMock or against the real database. So, for example, if I click what's up on Hacker News, yeah, so right now it uses test containers and it extracts data there. And if I want, so you can see that this is a backend I use, and if needed, I can connect it to the official Hacker News API to extract the real data. So how it's implemented in the code, WireMock, yeah, so this is this demo. So it's basically for Spring Boot developers, but yeah, again, the same can be done later for the application. So yeah, there is a bean that at the moment provisions WireMock container, and it uses particular version. It loads the stubs, so it happens on demand, and you can see that it's basically a configuration that can be replaced or activated depending on your needs. And in this application, so we use WireMock just as a standard container from the model. Yeah, this is basically our stub. It's much more worthy than I've presented before, because there are multiple dependencies, data that we need to list, and when the service will be extracting this data, it will be basically querying the same JSON. And then when we basically do the configuration, we can choose between this implementation or between other standard implementation that uses data loader. And in this application, we basically just extract the data that we want, and we will show all the stuff. You can see that there is actually quite a lot of code. But yeah, there's controller that basically goes to one instance or another. It just retrieves the data. It then maps the data to internal structures, and basically the client itself, etc., is totally agnostic. It uses the same API, whether it's a mocked service or not. And we just extract this data. Well, basically it's a database query, and then we can use it and develop our to-dos. So the good thing about this approach is that basically this development can be done live. So for example, if I add additional entries, etc., I can just refresh the application and it would run natively. To do that, we can actually use WireMock API, which is still available when you use in test containers. So it's not only a static application, and you can use dynamic features, for example, for logging, assertions, and also for all kinds of developer experience when you prototype a service. So if you're interested, try out this example. And if you want to reach out to me later, I can show similar examples for Quarkus, for Micronaut, and yeah, it's quite a handy framework.